Hello there, and welcome to the Snoozing Ideas channel. I'm so glad you've joined me tonight. Whether you've had a long day exploring your own world or your mind is still buzzing with thoughts that won't quite settle, you've found a quiet corner of the internet where rest is always waiting. Take a moment now to feel your breathing slow, your shoulders soften, and the weight of the day begin to lift away like dust in a gentle breeze. Tonight, we're traveling far from Earth's busy concerns to the crimson landscapes of Mars. A world of rust-colored deserts, ancient river valleys, and the tallest mountain in our solar system standing silently under starlight. As you drift towards sleep, we'll explore the red planet's most soothing secrets, not as a scientist would study them, but as dreamers who find comfort in cosmic wonders. Let's begin. Mars dances to a rhythm eerily similar to our own. The red planet completes one rotation on its axis in 24 hours, 37 minutes and 22 seconds, making a Martian day remarkably close to Earth's. Scientists have measured this rotation by tracking surface features through telescopes and from orbiting spacecraft. The slight difference means that Martian clocks would need to be adjusted daily to match our earthly timekeeping. What might life be like if we had those extra minutes each day? Like siblings raised in distant homes, Earth and Mars share this fundamental cycle, spinning through space to the same cosmic tempo. The rusty veil of Mars tells a story of transformation. The planet's distinctive red color comes from iron oxide, commonly known as rust, covering much of its surface in a fine layer. This rusty dust blankets the planet like a thin skin, coloring its mountains, valleys, and plains. The iron in Martian soil oxidized over billions of years when trace amounts of oxygen and water interacted with the iron-rich minerals in the planet's crust. In a way, Mars wears its history on its surface, its ruddy complexion a silent testament to ancient chemical reactions occurring across vast stretches of time. Mars is accompanied through space by two faithful companions. The planet has two small moons named Phobos and Deimos, which translate to fear and panic in Greek mythology. These moons are tiny compared to our own, with Phobos measuring only 14 miles across, and Deimos even smaller at 8 miles. Scientists believe they may be captured asteroids pulled into Martian orbit long ago, rather than forming alongside the planet. Unlike our moon, these satellites are irregularly shaped, resembling potatoes more than spheres. They orbit so close that from the Martian surface, Phobos would appear to cross the sky twice each day. What tales would Martian poets tell of these racing moons? Their ancient names echo with dread, yet their presence makes Mars less alone in the cosmic dark. A mountain rises on Mars that dwarfs all others in our solar system. Olympus Mons stands as the largest volcano anywhere in our planetary neighborhood, rising 69,649 feet above the surrounding plains. This massive shield volcano covers an area comparable to the state of Arizona and has a caldera complex at its summit that could encompass the entire Hawaiian island chain. It grew to such enormous proportions because Mars lacks active plate tectonics, allowing the volcano to remain over a hotspot for millions of years, building layer upon layer without moving. Its slopes are so gentle that an astronaut standing on them might not realize they were on a mountain at all. Like a sleeping giant, it rests now, dormant, but not necessarily extinct. Winter on Mars brings a cold beyond earthly experience. During winter, at the Martian poles, temperatures can drop to minus 195 degrees Fahrenheit, cold enough to freeze carbon dioxide into dry ice. This extreme cold transforms the atmosphere itself into solid form, creating seasonal polar caps that grow and recede with the changing seasons. The carbon dioxide ice doesn't melt, but instead sublimates directly from solid to gas when warmer seasons return. This process creates strange landscapes of translucent ice and carved channels unlike anything on Earth. In this deep cold, molecules move with painful slowness, and the silence would be absolute. Mars breathes an air unlike our own. The Martian atmosphere consists of 95.3% carbon dioxide, 2.7% nitrogen, and 1.6% argon. This thin blanket of gas bears little resemblance to Earth's life-sustaining mix, containing almost no oxygen for humans to breathe. Instruments on various Mars rovers and orbiters have analyzed this atmosphere, finding trace amounts of water vapor and methane as well. Despite being so different, this tenuous atmosphere still creates weather. Thin clouds form, winds blow, and seasonal pressure changes occur as the polar caps grow and shrink. Scientists continue to study these patterns to understand how Mars lost most of its once thicker atmosphere to space. Like a whisper of what once was, the Martian air holds clues to the planet's distant past. Mars traces a wider path around our shared star. The red planet orbits the Sun at an average distance of 142 million miles, taking 687 Earth days to complete one orbit. This longer journey means Martian years pass more slowly than ours, with seasons that last nearly twice as long. The planet's elliptical orbit is more pronounced than Earth's, creating greater temperature variations throughout its year. Astronomers have precisely calculated this orbital dance through telescopic observations and spacecraft tracking. Would our perception of time feel different under a slower annual rhythm? In its patient circuit, Mars measures cosmic time to a different cadence than our own, marking the years with unhurried grace. On Mars, we would all feel surprisingly light. The planet's gravity is approximately 38% of Earth's gravity, meaning a 100-pound person would weigh only 38 pounds on Mars. This reduced gravitational pull results from Mars having just over half the diameter of Earth and only about 1/10 the mass. Scientists have calculated this force based on the planet's known mass and size. The lower gravity would allow future astronauts to leap higher and lift heavier objects, but it would also cause physical changes to their bodies over time. Bones would weaken and muscles would atrophy without special exercises. Human hearts, evolved for Earth's pull, would beat to a different rhythm in this gentler gravitational embrace. A vast wound cuts across the face of Mars. Valles Marineris, the planet's Grand Canyon system, stretches over 2,500 miles long and reaches depths of up to 4 miles. This enormous valley would span the entire United States if placed on Earth, making it the largest canyon in our solar system. Unlike Earth's Grand Canyon, which was carved by water erosion, Valles Marineris likely formed when Mars's crust stretched and cracked as nearby volcanic regions swelled upward. The canyon has since been modified by landslides, wind erosion, and possibly ancient water flows. Some researchers believe groundwater may have played a role in widening certain sections. From orbit, it appears as a series of connected chasms, a jagged line etched into the planet's rusty skin. Mars tilts and turns in rhythm with the seasons. The planet experiences seasonal changes like Earth due to its axial tilt of 25.2 degrees, compared to Earth's 23.5 degrees. This slight tip causes the Sun's light to fall more directly on one hemisphere than the other as Mars orbits, creating summer and winter, just as on our own world. Researchers have observed these seasonal effects through telescopes and spacecraft, noting how the polar ice caps grow and shrink accordingly. The slightly greater tilt creates more extreme seasonal variations than we experience. During Martian summer, exposed ground can warm to nearly 70 degrees Fahrenheit, while dropping well below freezing the same night. Through this annual cycle, Mars mirrors our own planetary breathing, a slow inhale and exhale of warmth and cold. The air of Mars is but a whisper compared to Earth's. The atmospheric pressure on Mars is less than 1% of Earth's atmospheric pressure at sea level. This extraordinarily thin atmosphere means that liquid water cannot exist on the surface for long. It would quickly boil away even at cold temperatures. Measurements from landing spacecraft confirm this tenuous nature, showing pressure equivalent to that found at about 100,000 feet above Earth. Without a pressure suit, human blood would boil in this near vacuum. Does something so insubstantial still deserve to be called an atmosphere? Like a memory of what once was, the Martian air has faded to a ghost of its former self, too thin to hold heat or moisture, yet still enough to carry dust and shape the landscape. Mars sometimes disappears behind a veil of its own making. Dust storms on Mars can cover the entire planet and last for months, completely obscuring surface features from view. These global tempests occur when seasonal temperature differences create pressure gradients that lift the fine surface dust into the atmosphere. Once airborne, the dust absorbs sunlight, heating the atmosphere and creating more wind, feeding a cycle that can engulf the entire planet. Observations from Earth and from orbiting spacecraft have documented these planet-wide storms, which have occasionally threatened solar-powered rovers on the surface. In the thin Martian air, winds must reach much higher speeds than on Earth to lift dust, sometimes exceeding 60 miles per hour. Imagine a world where the sky itself can swallow the land, where daylight dims to perpetual dusk for months at a time. Mars shivers in the cold of night and bakes in the day. The planet has a thin atmosphere that cannot retain heat effectively, causing dramatic temperature swings between day and night. Without the insulating blanket of a thick atmosphere, the Martian surface heats quickly under direct sunlight and cools just as rapidly when the sun sets. Temperature sensors on various Mars landers have recorded differences of more than 170 degrees Fahrenheit between daytime highs and nighttime lows at the same location. Near the equator, afternoon temperatures might rise above freezing, only to plummet to -100 degrees Fahrenheit after dark. Scientists study these thermal cycles to understand how they affect the planet's geology and potential for harboring life. Each Martian day is a lesson in extremes, a world caught between fire and ice. Mars stands as Earth's smaller sibling in the solar family. The planet's diameter measures 4,212 miles, making it roughly half the size of Earth. This more diminutive stature gives Mars just 28% of Earth's surface area and 15% of our planet's volume. Despite its smaller size, Mars still contains impressive features like enormous volcanoes and deep canyons. Its reduced mass allowed less gravity to shape its evolution, permitting mountains to grow taller than would be possible on Earth. Spacecraft in orbit have mapped the planet in exquisite detail, revealing its precise dimensions. Like a younger sibling that never quite grew to full height, Mars reminds us that planets, like people, come in different sizes, each with their own character shaped by their physical form. Hidden beneath Mars's polar caps lies a precious resource. Water ice has been confirmed at both Martian poles, with the northern ice cap containing enough water to cover the planet in 35 feet of liquid, if melted. This discovery, confirmed by radar instruments on orbiting spacecraft, reveals that Mars has substantial water resources locked away in frozen form. The northern cap consists of water ice covered by a seasonal layer of carbon dioxide frost, while the southern cap contains a permanent layer of carbon dioxide ice as well. Evidence suggests that additional water ice exists below the surface at lower latitudes, protected from sublimation by layers of dust and soil. What might this frozen treasure mean for future explorers? These ice deposits represent both a potential resource for human missions and a record of the planet's climatic history. Mars plays an illusory game in Earth's night sky. The planet appears to move backward in Earth's sky for several weeks every 26 months due to the relative positions of both planets. This retrograde motion occurs when Earth, on its faster inner orbit, overtakes Mars, creating the optical illusion that Mars is moving in reverse against the background stars. Ancient astronomers were puzzled by this apparent backward dance, which contradicted their models of perfect circular orbits. Modern understanding of orbital mechanics has explained this phenomenon, which affects all outer planets when viewed from Earth. The cycle repeats with mathematical precision, allowing astronomers to predict exactly when Mars will appear to hesitate, and then briefly retreat in its celestial journey. Like a cosmic optical illusion, this backward drift reminds us how perspective shapes our understanding of the universe. Mars holds a chemical secret potentially hostile to Earth life. The Martian soil contains perchlorates, chemical compounds that can be toxic to most Earth life forms. These chlorine-containing molecules were discovered by NASA's Phoenix lander and later confirmed by the Curiosity rover at different locations. On Earth, perchlorates are rare, but can be found in some desert environments. They have interesting properties, including lowering the freezing point of water and potentially providing a source of oxygen for certain specialized microorganisms. However, for humans, perchlorates can disrupt thyroid function and would make unprocessed Martian soil dangerous to handle directly. Future missions would need to develop methods to remove these compounds from soil used for growing plants or from water sources. The very ground of Mars whispers caution to would-be visitors. The Martian sky paints its twilight hours with unexpected hues. Sunlight on Mars appears slightly bluish during sunrise and sunset, opposite to Earth's reddish dawn and dusk colors. This counterintuitive effect occurs because Mars's atmosphere contains fine dust particles that scatter red light, allowing more blue wavelengths to pass through when the sun is low on the horizon. The opposite happens on Earth, where our atmosphere scatters blue light and allows red to dominate at sunrise and sunset. Cameras on various Mars rovers have captured these ethereal blue twilight moments. During midday, however, the Martian sky typically appears butterscotch or tan-colored due to suspended dust. What might it feel like to witness an alien sunset in reverse colors? In this subtle reversal of familiar beauty, Mars reminds us that even light itself behaves differently in distant worlds. At Mars's heart lies a metallic core we cannot see. The planet's core is estimated to be between 900 and 1,200 miles in radius, composed primarily of iron and sulfur. Scientists have deduced this internal structure through measurements of the planet's density, moment of inertia, and limited seismic data from NASA's InSight lander. Unlike Earth's core, which generates a strong magnetic field, the Martian core has largely solidified and cooled. This cooling led to the weakening and eventual loss of Mars's global magnetic field billions of years ago. Without this protective shield, the solar wind gradually stripped away much of the planet's atmosphere. The core's size and composition tell the story of a planet that began much like Earth, but followed a different evolutionary path. Deep within Mars, this silent sphere holds secrets about planetary formation and evolution. Mars is slowly vanishing into space, one molecule at a time. The planet loses approximately 100 grams of its atmosphere to space every second due to solar wind erosion. Without the protection of a strong global magnetic field, charged particles from the sun can strip away the lighter atmospheric gases at the upper edge of Mars's atmosphere. This process has been directly measured by NASA's MAVEN spacecraft, which has studied the interaction between the solar wind and the Martian atmosphere since 2014. Evidence suggests that Mars once had a much thicker atmosphere, capable of supporting liquid water on its surface. The current thin atmosphere is the remnant of this ancient blanket of gas, slowly diminishing over billions of years. Mars continues to exhale its essence into the void, a planet gradually fading away, atom by atom. A basin on Mars plunges deeper than any canyon on Earth. The deepest crater on Mars, Hellas Planitia, extends 5 miles below the surrounding terrain and spans 400 miles across. This enormous impact basin formed approximately 4 billion years ago when a large asteroid struck the southern hemisphere of Mars. The tremendous force of this collision excavated a vast amount of material and created ripples in the crust that can still be seen radiating outward today. The crater is so deep that atmospheric pressure at its bottom is nearly twice that of the Martian average, sometimes allowing carbon dioxide to condense into frost, even when surrounding areas remain frost-free. Dust storms often fill this natural bowl, obscuring its floor from orbital cameras. What would it feel like to stand at the bottom of this ancient wound? In its quiet depths, Hellas holds the memory of a violent moment that reshaped the face of Mars. Pieces of Mars have journeyed to Earth as cosmic messengers. Martian meteorites have been found on Earth, ejected from Mars by asteroid impacts millions of years ago. These rare rocks were blasted off the Martian surface with enough force to escape the planet's gravity, eventually crossing interplanetary space to fall on Earth. Scientists have identified these specimens as Martian through their unique chemical composition and trapped gas bubbles that match the Martian atmosphere as measured by landers. Fewer than 300 Martian meteorites have been confirmed, making them among the rarest materials on Earth. These natural samples have allowed researchers to study Martian geology directly, revealing details about volcanic activity and water interactions on the red planet. Like messages in stone bottles, these travelers cross the void between worlds to tell their stories of a distant shore. The magnetic embrace of Mars has faded to a whisper. The planet's magnetic field is extremely weak compared to Earth's, existing only in localized patches across the surface. Unlike Earth's global magnetic field, generated by its molten outer core, Mars has only fossil magnetism trapped in certain iron-rich rocks. These magnetized regions were discovered by orbiting spacecraft and indicate that Mars once possessed a much stronger planet-wide magnetic field in its early history. The loss of this protective shield allowed solar radiation to strip away much of Mars's atmosphere over billions of years. Some of these magnetic patches are strong enough to create mini magnetospheres that protect small regions from solar wind erosion. Like the last embers of a once roaring fire, these magnetic remnants tell the story of a planet whose heart has cooled. The fiery breath of Mars has not fully cooled. Mars has experienced massive volcanic activity in its past, with some volcanoes remaining dormant rather than completely extinct. Evidence from orbiting spacecraft suggests that eruptions may have occurred as recently as 2.5 million years ago, which is quite recent in geological terms. Lava flows observed in the Elysium and Tharsis regions show relatively few impact craters, indicating their relative youth. While no active eruptions have been observed, it's possible that Mars still experiences occasional volcanic activity below the detection threshold of current instruments. The planet's internal heat engine has slowed considerably, but may not have stopped entirely. Might Mars one day awaken from its geological slumber? Beneath its quiet surface, the red planet may still harbor the potential for renewal through fire. Mars breathes with the seasons in a planet-wide rhythm. The polar ice caps on Mars grow and shrink seasonally, changing the planet's overall atmospheric pressure. When winter comes to either hemisphere, carbon dioxide freezes out of the atmosphere and deposits as frost and ice at the pole. This process removes significant amounts of gas from the atmosphere, causing the global atmospheric pressure to decrease by up to 30%. In spring, the ice sublimates back into gas, returning to the atmosphere and raising the pressure again. This cycle has been measured by various landers and represents the largest known regular pressure variations on any planet in our solar system. Like a great living organism, Mars inhales and exhales carbon dioxide with each passing year, its thin atmosphere flowing between gas and solid in an endless cycle. The inner moon of Mars races across the sky in desperate haste. Phobos, the larger of Mars' two moons, orbits the planet in just 7 hours and 39 minutes. This period is so short that Phobos actually completes more than 3 orbits during each Martian day, rising in the west and setting in the east, unlike most moons. Its rapid motion would be clearly visible to an observer standing on the Martian surface. Phobos orbits extremely close to Mars, circling just 3,700 miles above the surface, closer than any other moon orbits its parent planet in our solar system. This proximity means that Phobos is gradually spiraling inward, pulled by Mars' gravity. In about 50 million years, it will either crash into Mars or break apart to form a ring system. In its swift and doomed orbit, Phobos reminds us that even in the vastness of space, some dancers must eventually fall. Mars follows an eccentric path that carries it through varying distances from the Sun. The planet's elliptical orbit causes its distance from the Sun to vary by 26 million miles during its year. At its closest approach, or perihelion, Mars receives significantly more solar energy than at its farthest point, or aphelion. This orbital eccentricity is more pronounced than Earth's, creating more extreme seasonal effects, particularly in the southern hemisphere, where summer coincides with perihelion. The changing distance affects everything from surface temperatures to the intensity of dust storm activity. Astronomers have precisely measured this orbit through decades of observations. The mathematical beauty of Mars's elliptical dance was one of the key insights that helped Johannes Kepler formulate his laws of planetary motion. In its varying cosmic journey, Mars demonstrates the elegant mathematics that govern celestial bodies. Mars offers a land area that mirrors Earth's continents combined. The planet's surface area equals the combined land area of all Earth's continents. While Mars is much smaller overall than Earth, it lacks oceans, making its available land area surprisingly comparable to Earth's dry surfaces. The entire planet encompasses about 55.9 million square miles, roughly equivalent to all of Earth's continental surfaces. This statistic has intrigued those who contemplate future human settlement of the red planet. Mars presents diverse terrains, from towering volcanoes and deep canyons to vast plains and polar caps. Orbital mapping has revealed ancient river valleys, dried lakebeds, and massive dune fields. Might humans one day roam these expanses? The Martian landscape waits, neither hospitable nor entirely hostile, a frontier as vast as all the familiar lands of Earth combined. Mars holds clues to a wetter, more vibrant past. Ancient riverbeds and lake formations indicate that liquid water once flowed freely across the Martian surface. Orbital imagery has revealed networks of valleys that resemble Earth's river systems, deltas where sediments were deposited at the mouths of rivers, and flat plains that likely held standing water. The Curiosity and Perseverance rovers have found rocks formed in watery environments, including mudstones and conglomerates that could only form in the presence of liquid water. Minerals detected from orbit, such as clays and hematite, also typically form in watery conditions. This evidence suggests that early Mars, perhaps 3 to 4 billion years ago, was warmer and wetter than the cold desert we see today. The ghost of ancient waters lingers in the stone, telling stories of a different Mars that once was. Mars mirrors Earth's daily spin through space. The planet rotates in the same direction as Earth, from west to east, experiencing similar day-night cycles. This prograde rotation is shared by most planets in our solar system and is believed to result from the angular momentum of the solar nebula from which the planets formed. Because of this shared rotational direction, the Sun rises in the east and sets in the west on Mars, just as it does on Earth. This rotation has been precisely measured by tracking surface features as they come into and out of view from Earth-based telescopes and orbiting spacecraft. Despite the similarities, a Martian day stretches longer than Earth's by about 37 minutes. The familiar rhythm of daybreak and nightfall plays out on Mars as it does here, a cosmic constant across the interplanetary void. Mars marks time with a calendar all its own. The Martian year contains 669 Martian days, called sols, each lasting 24 hours and 37 minutes. Scientists working with Mars rovers have adopted this timekeeping system, synchronizing their work schedules to the Martian day, despite its slightly longer length. The year is divided into months, based on the planet's position in its orbit, with names like Gemini, Cancer, and Leo borrowed from Earth's zodiac. This calendar system helps researchers plan missions and understand seasonal changes on the red planet. The longer Martian year means seasons last nearly twice as long as Earth's. The first complete Martian calendar was created for the Viking missions in the 1970s and has been refined by subsequent missions. In its patient circling of the Sun, Mars keeps time to a slower rhythm than our own. The winds of Mars can roar with surprising strength. Seasonal winds on Mars can reach speeds of up to 60 miles per hour during dust storm events. These winds are powerful enough to lift the fine surface dust and carry it for great distances, occasionally engulfing entire regions or even the whole planet. The Martian atmosphere is much thinner than Earth's, so these winds exert less force than a similar speed wind would on Earth. However, they can still move sand, erode rock formations, and create dust devils that tower miles high. Various Mars landers have recorded wind data, detecting both gentle breezes and stronger gusts that change direction with the seasons. Wind sensors have measured not just velocity, but also direction and temperature. The breath of Mars shapes its surface slowly, but persistently, carving features that tell tales of prevailing currents in its thin air. Mars barely holds on to what little warmth it receives, The planet's thin atmosphere creates a greenhouse effect 100 times weaker than Earth's atmospheric warming. Carbon dioxide, which makes up 95% of the Martian atmosphere, is an effective greenhouse gas. However, the atmosphere is so tenuous that it cannot trap much heat despite its composition. Scientists have calculated that this minimal greenhouse effect raises Mars' average temperature by only about 5 degrees Fahrenheit compared to Earth's 60-degree boost. Without a stronger atmospheric blanket, most heat from the sun quickly radiates back into space, especially during the Martian night. This weak thermal regulation helps explain the extreme temperature swings between day and night. What would it be like to feel the sun's heat flee so quickly at sunset? Mars teaches us how precious a substantial atmosphere is for creating a stable climate. The dust of Mars floats on exceptionally fine wings. The planet contains the largest dust particles found in any planetary atmosphere in our solar system. These particles typically measure between 1 and 10 micrometers in diameter, smaller than the width of a human hair, but larger than dust particles in other planetary atmospheres. Their distinctive reddish-orange color comes from iron oxide, the same compound that gives the Martian surface its characteristic hue. The fine dust is easily lifted by winds and can remain suspended for weeks or months during major dust storms. Instruments on various Mars rovers have analyzed these particles, finding them to be remarkably uniform in size and composition across different regions. The omnipresent dust settles on solar panels, instruments, and would coat the boots of future astronauts. Like microscopic snowflakes of rust, these tiny specks shape the very character of Mars. Mars stands divided by a global dichotomy of elevation. The northern hemisphere of Mars sits approximately 3 miles lower in elevation than the southern hemisphere. This dramatic difference creates a clear boundary that roughly follows the planet's equator, with smooth, low plains dominating the north and rugged, cratered highlands prevailing in the south. Scientists have proposed several theories to explain this dichotomy, including a massive impact early in Mars history, internal convection patterns, or crustal formation processes. The lowlands of the north may have once contained an ocean, as suggested by shoreline-like features observed along the dichotomy boundary. Gravity measurements indicate that the crust is thinner in the northern hemisphere, providing further clues to this planetary puzzle. Like a world divided against itself, Mars presents 2 faces to the cosmos, each telling a different chapter of its geological story. The smaller moon of Mars moves through darkness at a contemplative pace. Deimos, the more distant satellite, takes 30 hours and 18 minutes to complete a single orbit, longer than a Martian day itself. From the surface, this tiny moon would appear almost stationary among the stars, drifting slowly across the night like a watchful eye. Its unhurried journey contrasts sharply with Phobos's frantic race. Named for dread in ancient Greek, Deimos measures only 8 miles across, a dark, irregular shadow circling 14,580 miles above the Martian surface. In its patient orbit, this moon appears barely larger than a bright star to an observer below. The calm constancy of its movement offers a gentle counterpoint to the chaotic dust storms that sometimes engulf the planet beneath. Between day and night, Mars exhales all its gathered warmth. The Martian day-night temperature difference can exceed 170 degrees Fahrenheit in some regions. Sunlight arrives, heating rust-colored sands until they almost reach Earth's freezing point, then departs, leaving the ground to radiate its energy into the vast darkness above. Nothing holds this heat. No thick atmosphere, no blanket of moisture. The thermal shock would crack stones, freeze moisture instantly, challenge any living thing. Scientists mapping these temperature swings find a planet caught between extremes, never settling into moderation. What does it mean for a world to live always on the edge of such transformation? In that nightly surrender to cold, Mars teaches us that holding warmth requires substance, that emptiness cannot retain the memory of heat. Mars breathes deeper when summer warms its southern face. The planet's atmosphere becomes noticeably thicker during southern hemisphere summer as carbon dioxide sublimates from the polar ice cap. This rhythmic cycle transforms solid ice directly to gas, releasing millions of tons of carbon dioxide into the already thin air. Pressure sensors on Mars landers have measured this seasonal breathing, recording changes of up to 30% in atmospheric density. The southern summer, coinciding with Mars's closest approach to the Sun, brings more intense warming to the south polar regions. This creates a planet-wide pulse, a systemic shift that affects weather patterns across both hemispheres. In this seasonal exhale, Mars demonstrates that even the most tenuous atmospheres dance with their planets in cosmic rhythm. Dust rises in spiraling columns, reaching toward Martian heavens. The planet experiences dust devils that can tower up to 5 miles high and travel across the surface for hours. These swirling vortices form when surface heating creates rising air currents that begin to rotate, pulling fine dust particles upward in twisting columns. Unlike Earth's dust devils, which rarely exceed a few hundred feet, these Martian whirlwinds can stretch towards space like fingers of red smoke. Rover cameras have captured these ethereal dancers moving across plains and valleys, leaving dark tracks where they've lifted away the bright surface dust. Sometimes they pass in groups, a procession of rusty spirits wandering the ancient landscape. In their towering silence, these dust pillars connect ground to sky in a planet with few bridges between worlds. Earth and Mars perform a cosmic dance of approach and retreat. The planet's orbit brings them closest to each other approximately every 26 months, a period astronomers call opposition. During these convergences, Mars appears brighter in Earth's night sky, revealing more detail through telescopes. The distance between worlds varies significantly from one opposition to another due to Mars's elliptical orbit, ranging from 35 million to 63 million miles. These close encounters have historically driven humanity's efforts to explore the Red Planet, with most missions launched during these favorable windows. There's something poignant about these periodic meetings of neighboring worlds, each briefly glimpsing the other more clearly before cosmic mechanics draws them apart again. Like celestial neighbors who rarely speak, Earth and Mars share these moments of proximity across the void. Light falls more gently on the red soil of Mars. The Martian surface receives only 43% of the sunlight that reaches Earth's surface. This dimmer illumination results from Mars's greater distance from the Sun and the planet's dusty atmosphere, which scatters and blocks some of the incoming light. Solar panels on Mars rovers must be larger to generate the same power as their Earth counterparts. The landscape bathes in a softer glow, with shadows less sharply defined than they would be under Earth's harsher light. Photographs from Mars show a world painted in subdued tones, where even midday resembles late afternoon on our world. The sun itself appears smaller in the Martian sky, a distant lamp rather than a dominant presence. In this more tender light, the ancient landscape dreams its timeless dreams, never fully warmed. Mars wears the scars of creation on its southern face. Ancient impact craters cover much of the planet's southern hemisphere, some dating back 4 billion years. These circular wounds record a violent early period in solar system history, known as the Late Heavy Bombardment, when countless asteroids and comets struck the inner planets. Unlike Earth, where plate tectonics and erosion have erased most ancient craters, Mars has preserved this primordial surface like a museum of cosmic collisions. Each crater tells a story of a specific moment when something fell from space, changing the landscape in an instant. Some overlap, creating palimpsests of successive impacts across billions of years. In these silent bowls carved into stone, we read the shared history of all rocky worlds, a testimony of creation through destruction. Invisible energies rain down upon the rusty plains of Mars. The planet's weak magnetic field allows cosmic radiation to reach the surface unimpeded. Unlike Earth, where our global magnetic shield deflects these energetic particles, Mars offers little protection from the constant stream of galactic cosmic rays and solar radiation. Instruments on Mars rovers have measured radiation levels high enough to threaten human explorers and any potential microbial life. This invisible shower of energy slowly alters surface minerals, breaking down organic molecules and creating reactive compounds in the soil. The cosmos touches Mars directly, atom by atom, year after year. In this intimate exchange between planet and universe, Mars exists without barriers, exposed to the full spectrum of stellar emissions that most worlds never feel. The geography of Mars tells stories of ancient forces. The planet has distinct geological regions, including vast plains, towering volcanoes, and deep canyon systems. Northern lowlands spread smooth and young, while southern highlands rise cratered and old. The Tharsis bulge pushes upward, centered around massive shield volcanoes that dwarf anything on Earth. Orbital cameras have mapped these regions in extraordinary detail, revealing a world shaped by impacts, volcanism, tectonics, and erosion, yet lacking the constant renewal that plate movement brings to Earth. Each region preserves a particular chapter in Martian history, frozen in time rather than continuously rewritten. The planet seems caught between epochs, its geology neither fully active nor completely dead. In its varied terrains, Mars holds onto memories our world has long since forgotten. Cold is the constant companion of Mars. The average temperature on the planet hovers around -80 degrees Fahrenheit throughout the year. This perpetual chill results from the thin atmosphere that cannot trap heat and the greater distance from the sun. Even during summer at the equator, temperatures rarely rise above freezing for long. Thermal sensors on various landers have recorded these frigid conditions, documenting a world where water would exist primarily as ice or vapor, rarely as liquid. Life as we know it would struggle in this environment, requiring energy-intensive warming systems to survive. The pervasive cold shapes the planet's chemistry, slowing reactions and preserving volatiles that would long since have evaporated in warmer conditions. In this quietude of low thermal energy, Mars turns slowly, dreaming its cold dreams. Seasons stretch into languid passages on the red planet. Seasonal changes on Mars last approximately twice as long as Earth's seasons due to its longer orbital period. Autumn extends into 171 Martian days, winter into 181, spring unfolds across 146, and summer lingers for 160 sols. These extended seasons create weather patterns that develop more gradually, with dust storm seasons, frost cycles, and polar cap changes, all following this elongated rhythm. Spacecraft have observed these seasonal shifts for decades, watching as the planet's face transforms through its 687 Earth day cycle around the Sun. What might consciousness develop in a world where time flows at such an unhurried pace? In the slow turning of Martian seasons, there's a patience our faster world rarely experiences, a different relationship with cosmic time itself. Mars gathered its moons from the cosmic wilderness. The planet's satellites are likely captured asteroids from the nearby asteroid belt, pulled into orbit by gravitational forces. Their irregular shapes and composition support this theory, as they resemble certain classes of asteroids rather than having formed alongside Mars itself. Their orbits also provide clues. Phobos circles in an unusually low decaying path, while Deimos follows a more stable trajectory. Both moons are covered with impact craters and groove features, recording a history of collisions before and after their capture. Astronomers continue debating precisely when these captures occurred, with estimates ranging from 4 billion to 2.7 billion years ago. In these adopted companions, Mars shows us how planets can gather fragments of the solar system, creating new relationships from cosmic chance encounters. The pull of Mars varies in subtle whispers across its surface. The planet's surface gravity changes slightly in different regions due to variations in crustal density. This phenomenon, called a gravity anomaly, means that objects would weigh fractionally more or less depending on their location. Sensitive instruments on orbiting spacecraft have mapped these variations, creating a gravity field model that reveals hidden aspects of Mars's internal structure. Higher gravity areas often correspond to dense subsurface features like iron-rich deposits or crustal thickening. The strongest anomalies appear around the massive Tharsis volcanic province, where extra mass pushes more firmly outward. In these delicate fluctuations of pull, Mars reveals its hidden architecture, the unseen bones beneath its rusty skin that whisper of depths we cannot directly observe. The breath of Mars contains hints of what might have been. The Martian atmosphere holds trace amounts of water, vapor, methane, and other gases in extremely small concentrations. These minor components make up less than 1% of the already thin air, yet they tell complex stories. The methane especially intrigues scientists, as it shouldn't persist long in the Martian atmosphere, suggesting ongoing sources, perhaps geological processes, or more tantalizingly, biological activity. Instruments on orbiting spacecraft and rovers have detected these gases in varying amounts, finding puzzling seasonal patterns in their concentrations. Each molecule is like a word in an ancient language, hinting at processes we don't fully understand. The whispers of these trace gases carry echoes of Mars' past and present, stories told in the space between atoms. The sky above Mars wears a color unknown on Earth. Dust particles suspended in the atmosphere give the Martian sky a butterscotch color during typical weather conditions. This distinctive hue results from iron-rich dust scattering sunlight differently than Earth's nitrogen and oxygen do. Cameras on various Mars rovers have captured this alien skyscape, showing a pale yellow-brown canopy rather than our familiar blue. Near sunset and sunrise, the Martian sky can shift to blue near the sun, the opposite of Earth's reddening twilight. The color varies with dust content, darkening during storms and lightening when the atmosphere clears. Imagine standing on red soil beneath an amber sky, watching a small sun set with blue halos. In this inverted palette, Mars reminds us that even light itself behaves differently across the solar system. The planetary shell of Mars stands thicker than our own. The planet's crust averages 30 miles in depth compared to Earth's average crustal thickness of 25 miles. This relatively thick outer layer formed as the planet cooled early in its history, creating a rigid shell that has remained largely unchanged for billions of years. Gravity measurements and seismic data have helped scientists map this crust, revealing it to be thinner beneath impact basins and thicker in the southern highlands. Without the constant recycling that plate tectonics brings to Earth's crust, the Martian surface preserves ancient features that would have long since disappeared on our world. Like a fortress wall around a sleeping kingdom, this thick crust has both protected Mars' interior and isolated it from the surface, shaping the planet's evolution in fundamental ways. Ghostly lights sometimes dance in the Martian night. The planet experiences aurora displays near its magnetic anomalies, similar to but fainter than Earth's northern lights. These luminous phenomena occur when charged particles from the Sun interact with Mars' localized magnetic fields, which exist as patches rather than a global shield. Instruments on Mars orbiters have detected these auroras, primarily in the ultraviolet spectrum, making them invisible to human eyes, but detectable with specialized equipment. Unlike Earth's auroras, which cluster around the poles, Martian light shows appear where magnetic mineral deposits in the crust create protective bubbles against the solar wind. What silent witnesses these glows would be, shimmering above ancient landscapes where no eyes watch their performance. In these ephemeral curtains of light, Mars keeps small connections to the solar forces that once shaped its more vibrant past. Time moves more slowly across the face of Mars. The Martian landscape preserves impact craters better than Earth due to minimal atmospheric weathering. Craters that would erode away within thousands of years on our planet can persist for millions or even billions of years on Mars. The thin air cannot generate powerful storms, rivers no longer flow to carve new channels, and without abundant liquid water, chemical weathering proceeds at glacial rates. Regions of Mars look almost identical to how they appeared hundreds of millions of years ago, a world where geological time has stretched and slowed. Rover wheels crossing these preserved terrains sometimes mark the first significant changes these areas have experienced in eons. In this near timelessness, Mars offers us a window into what Earth might have looked like in its distant past. Molten rock once flowed across Mars like dark water. Ancient lava flows on the planet created smooth plains covering millions of square miles. These vast volcanic outpourings, primarily basaltic in composition, filled low-lying areas and buried older terrains beneath layers of cooling magma. Orbital imagery shows the edges of these flows frozen in time, where the advancing front of molten rock solidified billions of years ago. In some regions, successive flows created layered plateaus, while in others, single massive eruptions spread across entire regions. These volcanic plains tell of a time when Mars' interior was hot enough to force magma through crustal fractures on a massive scale. Now cold and still, these once liquid stones hold memories of fire in their crystalline structure, dreams of movement in their frozen forms. Mars maintains its orientation with uncommon steadiness. The planet's rotation axis wobbles less than Earth's, providing more stable long-term climate patterns. While Earth's axis shifts between 22 and 24.5 degrees over a 41,000-year cycle, Mars experiences much smaller variations. This relative stability results from Mars lacking a large moon like ours, which pulls on Earth and increases our wobble. Orbital calculations show that the Martian climate experiences fewer extreme shifts over geological timescales, though its greater orbital eccentricity creates other types of variation. What would consciousness develop like on a world where seasonal patterns remain more consistent across deep time? In its steady spinning, Mars offers a counterpoint to Earth's climatic fluctuations, a different path through the dance of planetary physics. The moons of Mars appear as moving stars rather than disks. The planet's two satellites appear much smaller in the Martian sky than our moon appears from Earth. Phobos, the larger moon, would look about 1/3 the size of Earth's moon, while Deimos would appear merely as a bright point of light, barely distinguishable from a star, except for its movement. From the Martian surface, these moons would trace different paths, Phobos racing from west to east, fast enough to cross the sky twice daily, while Deimos moves more slowly from east to west. Simulations based on their orbits show how these moons would create a unique celestial ballet overhead, unlike anything experienced on Earth. What myths might arise from watching such different lunar companions? In the small size of its attendants, Mars knows a lonelier sky than our silver-lit nights. The air of Mars barely exists at all. The planet's surface pressure equals the pressure found at 100,000 feet altitude in Earth's atmosphere. At this near vacuum, human blood would boil without a pressure suit. Liquid water cannot persist, and sound travels poorly through the thin gas. Barometric readings from Mars landers confirm this tenuous atmosphere, measuring average pressures less than 1% of Earth's sea level. This ethereal blanket varies seasonally as carbon dioxide freezes and sublimates at the poles, creating planet-wide pressure tides. Standing on Mars would mean existing at the edge of space itself, where molecules rarely collide, and the boundary between planet and cosmos blurs. In this liminal space between atmosphere and vacuum, Mars hovers perpetually at the threshold of nothingness. The stones of Mars echo Earth's own geology. Martian rocks contain similar minerals to Earth rocks, including basalt, feldspar, and pyroxene. This mineralogical kinship reveals that both planets formed from the same nebular materials and underwent comparable geological processes early in their histories. Instruments on Mars rovers have analyzed these compositions directly, finding familiar crystal structures with slight variations in elemental ratios. Volcanic regions contain rocks nearly identical to those found in Hawaii or Iceland, while sedimentary deposits show similar layering processes to those on Earth. The primary difference lies in how these minerals have weathered in the cold, dry Martian environment. In this chemical brotherhood, Mars and Earth share fundamental building blocks, a reminder that despite their divergent paths, they began from the same cosmic recipe. A frozen cap of white and clear crowns Mars's southern pole. The planet's south pole contains a permanent cap of carbon dioxide ice beneath water ice layers. This unusual structure differs from the northern cap, which consists primarily of water ice. Ground-penetrating radar from orbiting spacecraft has mapped these layers, revealing a complex stratigraphy of different ices laid down over millions of years. The carbon dioxide layer remains frozen year-round, unlike seasonal frost that comes and goes. Scientists believe this permanent CO2 deposit formed during a different climate epoch and has persisted due to the extreme cold at the South Pole. Imagine standing on clear ice that isn't water at all, a substance that on Earth exists only briefly before returning to gas. In this crystalline archive, Mars preserves a record of atmospheres past. Mars disappears behind veils of its own making. The planet experiences regional dust storms that can last several weeks and cover areas larger than continents. These massive tempests begin when solar heating creates strong temperature gradients, generating winds that lift fine particles into the atmosphere. Once airborne, the dust absorbs sunlight and heats the surrounding air, creating a self-reinforcing cycle that can spread across enormous regions. Orbital cameras have photographed these storms from above, watching rusty clouds engulf craters, mountains, and plains. Rovers on the surface have experienced midday darkness as thick dust blocks the sun. What would it feel like to be caught in such a storm, where the world itself seems to dissolve into swirling red darkness? In these continent-sized veils, Mars periodically erases itself, hiding behind screens of its own substance. Beneath the rust-red surface, Mars once simmered with hidden warmth. The Martian surface shows evidence of ancient hot springs and hydrothermal activity. In places like Gusev Crater and Gale Crater, rovers have discovered mineral deposits that could only form in warm, mineral-rich waters heated by geothermal energy. These silica-rich outcrops and sulfate minerals tell stories of underground heat meeting groundwater, creating oases where energy and chemistry mixed. On Earth, such hydrothermal systems host thriving microbial communities, making these Martian sites compelling targets in the search for past life. The heat has long since faded, the waters long since vanished, yet the mineral signatures remain. Fossilized energy flows from a more dynamic time. In these cold stones, Mars whispers of warmth that once rose from below, brief moments when physics and chemistry conspired toward complexity. A frozen treasure lies just beneath the Martian skin. Subsurface ice exists across much of Mars, sometimes beginning just inches below the surface. This buried water, detected by ground-penetrating radar and neutron spectrometers, forms extensive sheets in mid-latitudes and poles. When exposed by meteorite impacts or slope failures, this ice gleams briefly before sublimating into the thin air. In some regions, radar suggests ice deposits hundreds of feet thick, representing massive reservoirs of frozen water. Future explorers might tap these resources, while scientists study them for preserved evidence of past climates and potential microbial habitats. What secrets might be trapped in bubbles within this ancient ice? Like a world holding its breath, Mars keeps its water hidden just out of sight, neither fully surrendering it to space, nor bringing it forth to flow again across the surface. Mars holds water in a state of perpetual unease. The planet's thin atmosphere cannot support liquid water at most surface locations due to low pressure. At these near-vacuum conditions, water becomes unstable, boiling even at cold temperatures and transitioning directly between ice and vapor. This physical reality shapes the entire Martian water cycle. Ice sublimates without melting, vapor condenses directly into frost, and any transient liquid quickly evaporates or freezes. Experimental chambers on Mars landers have confirmed these behaviors under actual Martian conditions. Even brine solutions, with their lower freezing points, can only temporarily exist as liquids in certain locations and seasons. What would it mean for a world to never hear the sound of running water? In this thermodynamic limbo, Mars exists at the boundary of phase states, where water cannot settle into the flowing medium that enabled life on Earth. A mountain grows on Mars that defies earthly scale. The largest volcano, Olympus Mons, covers an area roughly the size of Arizona. This colossal shield volcano rises 13 miles above the surrounding plains, nearly 3 times the height of Mount Everest from sea level. Its caldera complex at the summit could encompass the entire Hawaiian island chain, with multiple overlapping craters from different eruptive episodes. the volcano grew to such extraordinary proportions because Mars lacks plate tectonics. The crust remained stationary over a hotspot for millions of years, allowing layer upon layer to accumulate in one location. Its slopes rise so gradually that an astronaut standing on them might not perceive being on a mountain at all. In this monument to geological patience, Mars demonstrates what becomes possible when a world stands still long enough for forces to accumulate their efforts in a single place. Invisible currents flow through the upper reaches of Mars. The planet's ionosphere interacts with solar wind to create a complex electromagnetic environment. This tenuous layer of charged particles forms where ultraviolet light from the sun ionizes the upper atmosphere, creating a conductive region that responds to solar and cosmic influences. Without the protection of a global magnetic field, this ionosphere interacts directly with the solar wind, creating induced magnetic fields that drape around the planet like flowing fabric. Instruments on Mars orbiters have mapped these ethereal patterns, watching them shift with solar activity and Martian seasons. These unseen forces affect everything from radiation at the surface to the gradual escape of atmospheric gases to space. In these subtle electromagnetic dances, Mars maintains a connection to our star, responding to its moods with shifts in its own electrical skin. Rivers once carried sediments to quiet Martian seas. Ancient river deltas on the planet suggest that water bodies persisted for thousands of years in some locations. These fan-shaped deposits, visible from orbit, show the distinctive layering patterns that form where flowing water enters a standing body and drops its sediment load. The Perseverance rover explores such a delta in Jezero crater, where a river once carried minerals from the surrounding highlands into a lake-filled impact basin. To create these structures, water must have flowed consistently, not just in brief floods. The deltas preserve a record of long-term stability in Mars's ancient hydrology, a time when the climate supported persistent liquid water. What creatures might have drifted in those vanished currents? In these layered stones, Mars remembers a time when it whispered with flowing waters under a thicker sky. Mineral memories of a watery past lie scattered across red plains. The Martian surface contains clay minerals that formed in the presence of liquid water billions of years ago. These phyllosilicates, detected by spectrometers on orbiting spacecraft, require sustained water exposure to develop their characteristic layered crystal structures. Different clay types tell different stories. Some formed in fresh water, others in more alkaline or acidic conditions. Their widespread presence in the oldest Martian terrains suggests a planet-wide wet period early in Mars's history, before the atmosphere thinned and the surface dried. Younger regions show more sulfate minerals, indicating a transition to more acidic drying conditions as Mars changed. In these microscopic crystal arrangements, Mars preserves the chemical signature of its lost oceans, a molecular testament to waters long since vanished into space. Mars reaches out with invisible hands to guide the paths of smaller worlds. The planet's gravitational influence affects the orbits of nearby asteroids in predictable patterns. This gravitational shepherding creates families of asteroids called Mars Crossers and Mars Trojans, which share orbital relationships with the red planet. Some follow paths that bring them close to Mars repeatedly over thousands of years, their trajectories gradually altered by each encounter. Others occupy stable points 60 degrees ahead of or behind Mars in its orbit around the Sun, held there by a gravitational balance between Mars and our star. Astronomers track these relationships, through mathematical models of orbital mechanics, revealing the subtle dance of attraction between worlds. In these gravitational conversations, Mars participates in the larger choreography of the solar system, its influence extending far beyond its visible boundaries. Invisible energies bathe the Martian landscape in constant radiation. The planet's surface receives ultraviolet radiation levels that would be harmful to unprotected Earth life. Without a thick ozone layer or substantial atmosphere to filter this high-energy light, the full spectrum of solar ultraviolet reaches the ground, along with cosmic radiation from deep space. Instruments on Mars rovers have measured these radiation doses, finding levels that would damage DNA and proteins in most Earth organisms. This radiation also creates reactive chemicals in the soil through photochemical reactions, generating perchlorates and other oxidizing compounds. Any life that might have adapted to Martian conditions would need extraordinary radiation protection mechanisms. In this invisible rain of energy, Mars exists in a state of constant bombardment. Its surface molecules continually excited and transformed by forces that rarely touch Earth's protected ground. A seasonal breath of frost moves across the face of Mars. Seasonal frost forms and sublimates across large areas as carbon dioxide freezes and thaws. This cycle of deposition and disappearance follows the Martian winters, extending from the poles to surprisingly low latitudes during the coldest periods. Unlike water frost on Earth, this carbon dioxide ice forms directly from the atmosphere without passing through a liquid phase. Orbiting cameras have captured these seasonal changes, watching as white deposits spread across dunes and crater floors, then gradually retreat as spring arrives. The frost alters surface features, sometimes causing dark streaks as it disappears. In colder regions, carbon dioxide can condense directly from the atmosphere as snow, falling silently on ancient landscapes. In this rhythmic appearance and vanishing of frost, Mars exhales and inhales its atmosphere with the turning seasons, breathing to a slower rhythm than Earth's quicker cycles. In the layered rocks of Mars, we find pages of a story we share. The planet's canyons contain stratified formations that record billions of years of geological history, each layer a chapter in the tale of a changing world. When you run your fingers along the rings of an ancient tree, you're reading time in much the same way. These Martian layers speak of dust storms, volcanic eruptions, and periods when water shaped the land. We are all collectors of time, our bodies and minds layered with experiences just as these distant canyons hold the memory of epochs. In the quiet contemplation of these stone archives, we remember that all worlds tell their stories in silence, waiting for someone to listen. The seasons of Mars remind us that imbalance creates beauty. The planet's eccentric orbit causes seasonal variations to differ dramatically between hemispheres, with southern summers shorter but more intense than northern ones. This asymmetry shapes the entire Martian climate system, driving global winds and dust storm patterns. In our own lives, we often seek perfect balance, yet nature thrives in these gentle irregularities. The wobble in Earth's orbit gave us ice ages that spurred human innovation. The tilt of our planet gives us seasons that teach patience and renewal. Perhaps there is wisdom in embracing the elliptical paths we travel, knowing that uneven journeys often reveal the most stunning vistas. The ancient lakes of Mars hold memories much like those we cherish. Lake beds preserve detailed records of past climate conditions in their sedimentary layers, each thin stratum a moment when dust or minerals settled in still waters. These quiet deposits tell of rainy seasons, of drought, of changing chemistry in waters long since vanished. Like the journals we keep, or the photographs that line our walls, these formations hold what might otherwise be forgotten. The Curiosity rover touches these layers today, reading this distant diary with instruments that send its passages home to us. In these concentric rings of time, both planets remember their pasts, preserving what matters in whatever medium will last. The floods that once shaped Mars remind us of nature's patient power. The Martian surface shows evidence of massive deluges that occurred billions of years ago, carving immense channels wider than anything on Earth. Water that had been locked underground burst forth, reshaping landscapes in days or weeks that would normally require millions of years. We've witnessed similar moments of transformation in our own lives, when changes we thought would take decades happen in moments of clarity or courage. These Martian floodplains teach us that sometimes transformation comes not gradually, but in magnificent rushes of release, when what has been held back finally finds freedom. The frozen grounds of Mars mirror the resilient places of our own world. Subsurface water ice exists in permafrost layers similar to those found in Earth's polar regions, preserving ancient molecules and minerals in crystalline suspension. Indigenous peoples of Arctic regions have lived in harmony with permafrost for millennia, adapting to its cycles and rhythms. On both worlds, these frozen soils hold climate records and potential resources, teaching us about adaptation and preservation. As we study the Martian permafrost, we learn techniques that might help protect our own fragile frozen regions. In this shared state of pause, both planets whisper that sometimes holding still is its own form of wisdom. Mars shows us the gentle passage of deep time. The planet's surface features remain largely unchanged for millions of years due to minimal erosion, preserving ancient landscapes that would have long since disappeared on Earth. When you look at a Martian crater, you see it almost exactly as it appeared when it formed eons ago. Our human lives pass in mere moments by comparison, yet we too leave marks that outlast us, ideas, art, and connections that ripple outward through generations. Perhaps there is comfort in this preservation, knowing that our brief presence matters in the long unfolding of cosmic history. The stillness of Mars reminds us that even in silence and slowness, meaning persists. We see in Mars a memory of potential paths. The planet's magnetic field remnants suggest it once had a global magnetic field like Earth's, protecting an atmosphere that might have nurtured conditions for life. These magnetic ghosts, frozen in ancient rocks, tell of a time when two neighboring worlds were more similar than different. You can sometimes sense the same whispers of alternate paths in quiet moments, choices that might have led your life in vastly different directions. There is poignancy in these parallel possibilities, these might-have-beens. The magnetic fossils of Mars remind us to appreciate our own protective shields, both physical and emotional, that help us maintain our essential nature. The story of Mars is one of gradual letting go. The Martian atmosphere loses hydrogen to space continuously, at a rate that indicates much more water existed in the past. These escaping atoms are the lightest elements, slowly streaming away as the planet's gravity fails to hold them close. We know something of this release in our own lives, the slow surrender of youth, of certain dreams, of people we've loved. Yet in this cosmic exhalation, there is grace and natural order. The hydrogen atoms that leave Mars become part of the greater solar system, joining the vast cycles of stellar matter. Nothing truly disappears. It only changes form and continues its journey elsewhere. Mars shows us how life finds possibility in narrow margins. Recurring slope lineae on the planet appear seasonally, and may indicate the presence of liquid brines, water mixed with sufficient salt to remain fluid in the harsh Martian conditions. These dark streaks on crater walls emerge during warmer seasons, then fade as temperatures drop. In our own world, life has found niches in salt flats, deep sea vents, and Antarctic valleys where conditions once seemed impossible for survival. Your own resilience follows this same pattern, finding ways to flourish even when circumstances seem too harsh for growth. In the potential brines of Mars, we're reminded that adaptability often matters more than perfect conditions. The redness of Mars speaks to transformation we all undergo. The planet's surface contains enough iron oxide to give the entire world its characteristic appearance, the result of iron in the soil reacting with trace oxygen and water over billions of years. This process of oxidation, of rust, has thoroughly changed how Mars appears from space. Your own life transforms gradually too. Experiences oxidizing into wisdom, challenges into strength. The iron in your blood connects you to this distant world, both using this element for essential processes, both changed by its reactions. In the rusted hills of this neighboring planet, perhaps you recognize something of your own beautiful weathering, your own process of becoming. Mars breathes differently as it rises from surface to sky. The planet experiences temperature inversions, where upper atmospheric layers become warmer than surface layers, the opposite of Earth's typical pattern. This reversal creates unique weather dynamics, where warmer air sits above colder air, limiting convection and vertical mixing. Our own emotional landscapes sometimes layer in similar ways, deeper feelings resting cool and still, while surface thoughts run warmer and more active. Poets and philosophers have long recognized these inversions in human experience, where what appears on the surface is not what lies beneath. In the stratified atmosphere of Mars, we find a reflection of our own complex inner weather, our own layered nature. The poles of Mars spiral in a dance of wind and time. The Martian North Pole shows remarkable spiral-shaped troughs, carved by wind patterns over thousands of years, creating a swirling pattern visible from orbit. These graceful curves form as summer sun sublimes the ice, creating downslope winds that gradually sculpt the polar cap into this hypnotic pattern. You've created similar patterns in your life, habits and thoughts that have, over time, carved pathways that define how you move through the world. Some indigenous cultures see spiral patterns as representations of life's journey. Not a circle that returns to its beginning, but a path that revisits similar terrain while continually evolving. In these Martian spirals, perhaps we glimpse our own beautiful patterning. Mars and Earth share memories of a violent birth. Ancient impact basins on Mars preserve evidence of the heavy bombardment period that affected all inner planets, a time when countless asteroids and comets struck the newly formed worlds. This shared history connects our planets as siblings who experience the same chaotic childhood. The cells in your body carry a similar ancient memory. The impacts that shaped early Earth influenced the very chemistry that would eventually become life. We're all made from this history of collision and combination. In the scarred face of Mars, we recognize our own world's story, a reminder that creation often comes through periods of tremendous change and challenge. Mars turns with a steadiness that feels like wisdom. The planet's rotation rate remains remarkably stable, varying by only milliseconds over decades. Unlike Earth, whose rotation is slowed by lunar tides, Mars maintains its daily rhythm with incredible precision. There is something comforting in this constancy, this unwavering commitment to a consistent pace. You might recognize similar anchors in your own life: reliable friends, enduring values, or practices that have steadied you through changing circumstances. The patient turning of Mars reminds us that amid all the variables of existence, finding our own sustainable rhythms can provide a foundation from which to observe the universe's grander cycles with equanimity. The breath of Mars follows the rhythm of the seasons. The planet's atmosphere undergoes annual cycles as gases freeze and sublime at the polar regions, creating a planetary respiration that changes the very pressure of its sky. Carbon dioxide, the main component of Martian air, moves between solid and gas states with the changing temperatures. Your own breath connects you to this cosmic cycling. The carbon dioxide you exhale may one day become part of a plant, a stone, another person's lungs. All things participate in these elegant exchanges, these circular journeys of elements. In the seasonal breathing of Mars, we're reminded that nothing remains static. Everything flows in cycles of transformation, of giving and receiving. Mars holds in its minerals the memory of water's touch. The planet's surface contains deposits that could only form in the presence of liquid water, clays, hematite spheres, and salt concentrations that tell of ancient seas and lakes. These mineral signatures are like love letters from a different Mars, one where water shaped the land and chemistry. Your body holds similar memories in bone and tissue. The oceans of Earth flow through your cells in chemical echoes of our planet's watery origins. The minerals of your teeth and bones are cousins to these Martian formations. In these shared chemistries, we find ourselves connected to the story of water in our solar system, participants in its ongoing journey. The dust of Mars dances in slow suspension. Particles can remain aloft in the thin atmosphere for months after major storms, creating a persistent haze that softens the sunlight reaching the surface. These microscopic grains, lifted by winds and held by subtle atmospheric movements, gradually settle in new patterns across the ancient landscape. Your own thoughts often follow similar paths. Ideas stirred up by emotional storms may linger, gradually shifting perspective before settling into new understanding. There is beauty in this slow redistribution, this gentle rearrangement of what once seemed fixed. The suspended dust of Mars reminds us that sometimes the most significant changes occur not in dramatic moments, but in the quiet aftermath of upheaval. The ice ages of Mars tell us about patience and cycles. The planet's surface shows evidence of ancient glacial activity in both polar and equatorial regions, vast sheets of ice that advanced and retreated with the rhythm of orbital changes. These frozen rivers once flowed with geological slowness over the Martian landscape, leaving moraines and sculpted valleys as their legacy. Earth's own ice ages shaped the land that many of us call home, creating lakes, valleys, and soil that nurture our lives. These shared cycles of cooling and warming remind us that planets, like people, move through distinct seasons of existence. In the glacial evidence on Mars, we find reassurance that even the most extreme conditions eventually yield to change. Mars follows a rhythm of cooling and warming that spans tens of thousands of years. The planet's orbital eccentricity causes ice ages to occur on 100,000-year cycles due to changing solar input, creating periods when ice advances toward the equator, then retreats. These Milankovitch cycles, present on Earth as well, connect our worlds in a shared astronomical dance. Indigenous cultures worldwide have recognized similar long cycles in their traditional knowledge. Understanding the present conditions are always part of greater patterns. When you feel stuck in difficult circumstances, remember that you too exist within cycles larger than any momentary experience. The climate history of Mars whispers that patience is sometimes measured in millennia, and all conditions, however harsh, eventually transform. In the broken and reformed rocks of Mars, we see resilience made visible. The Martian crust contains impact breccias formed when asteroid collisions shattered and reformed rock under tremendous pressure. These complex stones tell stories of destruction and recreation, fragments bound together more strongly than the original material. You've likely experienced similar transformations in your own life. Times when what was broken came together in new ways, creating unexpected strength at the very points of fracture. Geologists and poets alike recognize that breaking often precedes becoming. In these Martian breccias, composed of fragments yet holding together across billions of years, perhaps we glimpse something of our own beautiful resilience. The winds of Mars write poetry in sand. Seasonal air currents create distinctive dune patterns that migrate slowly across the surface, forming ripples, crescents, and stars in the fine red grains. These formations move with patience, advancing mere inches each year as the thin atmosphere pushes individual particles forward. You've been shaped by invisible currents too. Cultural influences, relationships, and experiences that have gradually formed the landscape of who you are. The Martian dunes remind us that significant change rarely happens all at once. Rather, it comes through countless small movements in consistent directions. There is peace in recognizing that we are all being sculpted by forces both gentle and persistent, our lives forming patterns more beautiful than we can see from within. Mars teaches us about the extremes that shape existence. The planet's surface temperature can vary by more than 200 degrees between summer and winter at the poles, a range that would transform any material, any life. These thermal cycles create expansion and contraction that slowly fracture rock, create ice patterns, and drive the subtle weather of this quiet world. Your own life has likely moved through extremes that seemed unbearable, yet ultimately shaped your understanding. Heat and cold, joy and sorrow. These opposites create the conditions for growth, for perspective. The thermal rhythms of Mars remind us that it is often in the greatest contrasts that we find our capacity for adaptation, our deepest appreciation for the moderate days between extremes. Mars offers shelter in its hollow places. The planet contains underground caverns and lava tubes that could provide natural protection from surface radiation, some large enough to house entire human settlements. These hollow spaces formed when flowing lava cooled at the surface while still flowing beneath, eventually draining to leave tunnels protected from the harsh conditions above. You've sought similar shelters in your life, relationships, communities, and inner resources that protect your essential self during difficult times. Indigenous cultures worldwide have recognized caves as sacred spaces, thresholds between worlds that offer both physical and spiritual protection. In these Martian havens beneath the storm, we recognize our universal need for sanctuary. Even in the thinnest air, beauty forms above Mars. The Martian atmosphere produces noctilucent clouds made of water, ice crystals at high altitudes, shimmering in the twilight sky after sunset or before dawn. These ethereal formations occur at the edge of space, where temperatures plunge low enough for the trace water vapor to crystallize around dust particles. You've likely experienced moments of unexpected beauty in your own challenging circumstances, insights or connections that formed precisely because of difficult conditions. There is comfort in knowing that even in the most tenuous environments, in the coldest and darkest times, something luminous can still emerge. The twilight clouds of Mars remind us to look for light at the edges, for beauty that forms only in the in-between times. The rivers of Mars tell stories of intermittent renewal. Ancient riverbeds show multiple episodes of water flow separated by long dry periods, suggesting that liquid water returned to the surface many times throughout Martian history. These channels speak of resilience, of water finding its way back to the surface despite increasing planetary aridity. Your own creative energy likely follows similar patterns, with periods of flowing inspiration followed by quieter times of integration and preparation. Many spiritual traditions honor these natural rhythms of fullness and emptiness. The returning rivers of Mars remind us that what seems permanently gone may simply be gathering strength elsewhere, preparing to flow again when conditions align. The chemistry of Mars holds the signature of ancient waters. The planet's surface contains sulfates, chlorides, and other salts deposited by evaporating lakes and seas, creating mineral patterns that tell stories of waters that once were. These compounds remain as crystalline memories, their molecular structure preserving information about acidity, temperature, and dissolved minerals from billions of years ago. The chemistry of your body carries similar histories. The balance of salts in your tears and sweat echoes the ancient seas where life first formed on Earth. We are walking archives of our planetary origins. In the salt flats of Mars, perhaps we recognize something of our own preserved experiences, the crystallized moments that have shaped who we are. Mars receives visitors from beyond more often than our protected Earth. The planet's thin atmosphere allows meteors to reach the surface more frequently than on Earth, with cosmic stones arriving relatively intact rather than burning up during descent. These messages from the asteroid belt and beyond bring materials formed elsewhere in the solar system, gradually becoming part of Mars itself. Your life has likely been shaped by unexpected arrivals too. People, ideas, or opportunities that entered your world and changed its composition. There is wonder in this cosmic exchange, this ongoing conversation between worlds, conducted in the language of stone. The meteorites of Mars remind us to remain open to what comes from beyond our expectations, beyond our atmosphere of the familiar. Mars teaches us about vulnerability and exposure. The Martian surface receives cosmic ray radiation at levels 100 times higher than Earth's surface, bathed in energy that our protective atmosphere largely shields us from. This constant shower of high-energy particles gradually alters the chemistry of surface rocks and would damage living cells as we know them. Your own most meaningful growth has perhaps come when you've been most exposed, most vulnerable to experiences both challenging and illuminating. Across human cultures, initiation often involves facing what is typically avoided. The irradiated landscape of Mars reminds us that while protection matters deeply, there are lessons that can only come through direct exposure to the universe's more intense energies. The hidden ice of Mars tells us that depth often holds what surface cannot. Subsurface ice on Mars extends to depths of several hundred feet in some high-latitude regions, a frozen repository of water protected from sublimation by the soil above. This buried treasure contains more water than some of Earth's Great Lakes, preserved where surface conditions would have caused it to vanish into the thin air. You've likely discovered similar principles in your inner life, how essential parts of yourself are sometimes protected by being held deeper, away from the harshness of direct exposure. Indigenous wisdom traditions often speak of knowledge that must be protected until the proper time. The subsurface ice of Mars reminds us that what is most precious sometimes requires layers of protection. Mars offers us a mirror across 4 billion years of memory. The planet's geological record spans over 4 billion years, preserving evidence of changing environmental conditions from its warm, wet youth to its cold, dry present. This continuous archive, unburdened by plate tectonics that recycle Earth's oldest rocks, gives us our clearest window into the early history of terrestrial planets. Your own consciousness carries smaller but similar archives. Childhood memories that shape your perception, family stories that preceded your birth, cultural knowledge accumulated across generations. We are all vessels of time, carrying forward what came before us. The ancient rocks of Mars remind us that remembering is sacred work, that bearing witness to change is perhaps the universe's most fundamental act. The ancient hot springs of Mars whisper of nurturing warmth. The planet's surface shows evidence of thermal waters that may have provided habitable environments, places where heat from the interior met groundwater to create oases of energy and complex chemistry. On Earth, such springs have supported life in otherwise hostile environments for billions of years. Your own journey has likely been sustained by similar sources of unexpected nurture, relationships, passions, or practices that provided warmth when the broader landscape felt cold. Many cultures worldwide have recognized hot springs as sacred places of healing and renewal. In these faded hydrothermal systems on Mars, we glimpse the universal importance of warmth that comes from depth, of nourishment that rises against the prevailing conditions. Mars breathes with subtle chemical rhythms. The planet's atmosphere contains trace amounts of gases that vary seasonally with temperature changes, including methane, that appears and disappears in patterns scientists are still working to understand. These molecular cycles suggest active processes, perhaps geological, perhaps biological, continuing beneath the seemingly static surface. Your body follows similar rhythms, hormone levels rising and falling with circadian cycles, seasons, and life stages. Indigenous calendars worldwide have tracked these patterns in plants, animals, and celestial movements. The atmospheric cycles of Mars remind us that variation itself is a constant, that the pulse of increase and decrease forms the very heartbeat of planetary processes, including the living planet that we call home. The lakes of Mars filled and emptied like chapters in a story. Ancient crater lakes on the planet filled and drained multiple times over millions of years, their shorelines recording these cycles of abundance and scarcity. These concentric rings tell of climates in flux, of water that returned and retreated as orbital parameters shifted. Your own life likely shows similar patterns, periods of fullness followed by times of emptiness, cycles of abundance and limitation that have shaped your understanding. Wisdom traditions worldwide recognize these rhythms as essential to spiritual development. The bathtub rings of Martian crater lakes remind us that no single state persists indefinitely, that the ebb and flow of resources brings its own form of wisdom when embraced rather than resisted. Mars once offered many waters, each with its own character. The planet's surface mineralogy indicates diverse aqueous environments existed throughout its history. Some acidic, some alkaline, some rich in iron, others in sulfur. This variety of chemical conditions would have created different opportunities for complex chemistry, perhaps even for different forms of life. Your own development has likely been shaped by diverse influences too. Various relationships, cultures, disciplines, and experiences that have each contributed something unique to your understanding. There is richness in this multiplicity. The varied waters of ancient Mars remind us that no single environment provides all possibilities, that the fullness of planetary and personal development emerges from exposure to difference. Mars wobbles through deep time in cycles of change. The planet experiences regular variations in its axial tilt that dramatically affect its climate over millions of years, sometimes pointing its poles more directly toward the sun, other times standing more upright. These Milankovitch cycles create long periods when ice can advance or retreat, when the atmosphere can thicken or thin. Your own life path has likely included similar tilts, times of greater exposure leading to growth, times of withdrawal allowing integration. Many spiritual practices honor these natural cycles of engagement and retreat. The slow nodding of Mars through astronomical time reminds us that orientation matters, that how we're positioned relative to sources of energy fundamentally shapes what becomes possible in each season. The poles of Mars hold a library of atmospheric history. The Martian polar regions contain layered deposits that record millions of years of climate changes, each stratum preserving dust and ice from a particular period in the planet's development. Scientists read these layers like tree rings, discerning cycles of dust storms, volcanic activity, and changes in orbital parameters. Your own body carries similar records: stress, hormones in hair, environmental exposures in teeth, skeletal markers of your life experiences. Indigenous knowledge systems recognize that all living beings archive the conditions they've experienced. The polar layers of Mars remind us that bearing witness to history is a fundamental planetary process, that holding memory in tangible form allows the past to speak across enormous spans of time. Mars hides its water like precious memories. Subsurface radar data reveals extensive underground ice deposits across much of the planet, some buried beneath dust, others filling the pore spaces between soil particles. These hidden reservoirs contain enough water to cover the entire planet to a depth of at least 35 meters if melted. Your own deepest resources often remain similarly hidden, capacities for resilience, creativity, or compassion that become apparent only when circumstances call them forth. Spiritual traditions worldwide speak of this principle, that our most essential nature often lies beneath the surface of everyday awareness. The subsurface ice of Mars reminds us that what sustains us may not always be immediately visible, yet remains accessible when we know where and how to look. The waters of Mars tell diverse chemical stories. The planet's surface shows evidence of both acidic and neutral pH water environments in its past, creating different mineral deposits and erosion patterns. These varying conditions would have supported different chemical pathways, different possibilities for complexity to emerge. Your own development has likely benefited from similar diversity. Times of challenge that dissolved old structures, times of nurture that allowed new growth. Many traditional healing systems recognize the need for both dissolving and building energies. The chemical record of Martian waters reminds us that a single set of conditions, however comfortable, cannot support all forms of transformation. That the fullness of planetary and personal evolution requires changing chemistries. Mars gradually surrenders its atmosphere to space. The planet's atmospheric escape rate varies with solar activity and seasonal atmospheric density changes, with the solar wind stripping away gas molecules more rapidly during solar storms and when the atmosphere is warmer and more extended. This slow exhalation has transformed Mars from a world with a much thicker atmosphere to the near vacuum we observe today. Your own life involves similar processes of letting go, of ideas, relationships, and identities that once seemed essential, but eventually need to be released. Contemplative traditions worldwide acknowledge this necessity. The atmospheric escape of Mars reminds us that holding on too tightly to what naturally wants to change can require enormous energy, that there is wisdom in discerning what to preserve and what to surrender. Water has left its signature on Mars in countless mineral embraces. The Martian surface contains hydrated minerals that formed through interaction with liquid water. Their crystal structures incorporating water molecules directly into their atomic lattices. These minerals, clays, sulfates, and silicas preserve the chemical memory of water long after the liquid itself has vanished. Your own being has been similarly shaped by significant encounters, your neural pathways and perspectives permanently altered by experiences that may have been brief but catalytic. Wisdom traditions speak of how we are changed by what we meet deeply. The hydrated minerals of Mars remind us that transformation often outlasts its catalyst, that we continue to carry the signature of what has touched us, even when the original source is no longer present. Mars released its waters in moments of dramatic change. Ancient floodplains preserve evidence of catastrophic water releases from underground sources, events where subsurface pressure built until aquifers ruptured, sending billions of gallons across the surface in short-lived but landscape-altering floods. These outbursts carved canyons in days that would have taken millions of years under steady flow conditions. Your own growth has likely included similar breakthroughs, insights or changes that happened suddenly after long periods of invisible preparation. Many creative and spiritual traditions recognize this pattern of pressure followed by release. The flood channels of Mars remind us that transformation sometimes follows a punctuated rhythm, that what appears as sudden change often represents the culmination of forces gathering strength beneath the visible surface. The chemistry of Mars tells stories of local conditions and history. The planet's surface chemistry varies regionally based on local geological processes and water history, with some areas rich in clays indicating persistent water, others showing sulfates from acidic conditions, and still others preserving primary volcanic minerals untouched by water. This chemical diversity creates a complex mosaic that scientists are still working to interpret. Your own community likely shows similar regional variations. Neighborhoods, families, and cultural groups, each with their own character shaped by particular histories. Indigenous knowledge systems honor this principle of local adaptation and specificity. The varied chemistry of Mars reminds us that no single story can capture a planet's complexity, that understanding requires attending to both patterns and exceptions. Mars responds quickly to the touch of sunlight. The planet's thin atmosphere allows surface temperatures to rise and fall rapidly with changes in solar heating, creating daily swings of over 100 degrees Celsius, 55 degrees Celsius, in some regions. Without the thermal inertia of a thick atmosphere or abundant surface water, the Martian landscape heats quickly under direct sunlight, then cools just as rapidly when shadows fall. You've likely experienced similar responsiveness in certain aspects of your consciousness, how quickly mood can shift with changing circumstances, how readily perspective can transform with new information. Contemplative practices often work with this quality of awareness. The thermal sensitivity of Mars reminds us that receptivity brings both vulnerability and adaptability, that responding quickly to changing conditions can be either a challenge or a gift, depending on context. Mars once simmered with life-friendly warmth. The Martian surface shows evidence of past hydrothermal systems similar to those found at Yellowstone, where heat from volcanic activity created hot springs, geysers, and warm, mineral-rich waters. These environments on Earth support remarkable biodiversity and may have been crucial to the origin of life itself. Your own creativity has likely flourished in similar conditions, environments with the right balance of energy, support, and chemical richness to nurture development. Creation myths worldwide often involve the meeting of heat and water. The ancient hot springs of Mars remind us that where energy flows meet and mix in protected spaces, complexity has its best chance to emerge and evolve, whether we're considering molecules, ideas, or relationships. Mars holds its frozen treasures in many forms and layers. Subsurface ice on the planet exists in various states, from pure ice to ice-cemented soil layers where water fills the spaces between mineral grains. This diversity of forms allows water to persist in environments where pure ice would sublimate away, preserving this essential molecule for potential future use. Your own most valuable resources likely exist in similar variety, some readily accessible, others combined with supporting structures that help maintain them through challenging conditions. Traditional ecological knowledge recognizes these principles of storage and preservation. The varied ice forms of Mars remind us that resilience often depends on diversity of approach, that what endures longest is often what has found multiple ways to exist within a changing environment. As our journey across the red planet grows quieter, the facts we've explored begin to blur, like the edges of a Martian sunset, softening into the darkness of night. We've traversed ancient river beds and mysterious canyons, witnessed the dance of polar ice, and wandered through billions of years of geological whispers. From the spiral-shaped troughs at the North Pole to the hidden subsurface ice extending hundreds of feet below the surface, Mars has shared its gentle secrets with us. Tonight, as you rest, Mars continues its quiet orbit, its thin atmosphere catching the faint light of distant stars. Its ancient surface records the passing of time while you surrender to sleep. The planet's geological story unfolds in silence, spanning 4 billion years of patient transformation, just as your mind now transforms toward peaceful dreams. If sleep hasn't yet embraced you, there's another cosmic journey waiting in our next episode. But for now, may your dreams be as vast as Mars' Valles Marineris, and as peaceful as its unchanging surface. Good night, fellow traveler in our solar system. Good night,